Okay, welcome back, guys. Today we're going to be talking about solving linear systems with elimination. Just as a forewarning, this video is being made for stations activity. So if you're watching this at some point in the future, if you're not in my class and you just happen to come across this video resource, well, feel free to follow along. But for those of you that are doing this alongside the station's worksheet, be aware that the first portion of this video is going to be stuff that is not connected to your worksheet. It's just kind of connecting tissue between the things we've talked about before in class and now. Let's get into it. So when we're talking about solving these systems with elimination, I want you to remember that it's no different in terms of what the end product is than if you're solving with substitution or if you're solving with graphing, right? The idea behind each of these three methods in solving linear systems is to find the place where, if you were to graph your two linear equations, you would find this point right here of intersection, right? No matter what method you're using to solve, you're always looking for your solution, which is the place where your two linear functions cross on a graph. Now, keep in mind a couple of things. If you end up graphing two of the same line, right, you're going to end up with these coinciding lines that have infinitely many solutions, right? Two lines that are always going to be touching for as long as their domain exists. Alternatively, if you have two parallel lines, right, like lines that you know will never cross, what you can say about those two lines is that they have no solutions. They'll never intersect, and so there's no point of intersection, there's no solution. But as we've talked about previously, graphing is not always going to be a feasible method for solving because, maybe your numbers are just weird to deal with, or maybe making a graph is infeasible because your numbers are too large. Whatever the case may be, if you can't solve by graphing a system, you can usually try solving with an algebraic method, one of which is called substitution. That's one we've already talked about in our class. So if we take a look at the following system that you see here, x plus y equals 7 and x minus y equals negative 3. There is a way to solve this algebraically. It's a way that you've heard of prior to this point. It's called solving with substitution. All right, here's how it works. For solving with substitution to be a thing that we can do, we're going to have to figure out first the value for one of our variables, either the x's or the y's. All right, so we got to get one of those variables, x or y, by itself. In either case, it seems about equally difficult to get a variable by itself, and then it's actually pretty easy. Let me go ahead and decide to get this x by itself. All right, I'm going to take that equation, I'm going to pull it out. And so all that I have to do here to get y away and get x by itself is subtract both sides by y. Right? This is all pretty familiar to us. What that's going to do is it's going to cancel out the y's on the left side of the equal sign. Now we've got x by itself. And over here on the right side of the equal sign, we see 7 minus y. We can just write that as that, 7 minus y. Right? So substitution works when one of the variables is by itself. We've done that by taking that first equation and solving with x. We can now take that value for x that we found, 7 minus y, and we can plug it in for the x in the other equation. Remember, when you're solving a system, you're looking for the place where two lines intersect. That means their x values and their y values are identical. So let's go ahead and plug that x value we found back into the other equation. Instead of x, we're going to write it in green here so we can keep track of what it is we're filling in. 7 minus y equals negative 3. Again, remember what we just plugged in there was the value for x that we found from the other equation. Now we can go ahead and get to solving for y. We can drop our parentheses here because of the associative property, right? So 7 minus y equals negative 3. We can then decide to combine our like terms here. In this case, those like terms, I'll use pink for those, are going to be negative y and negative y. And so combining those, we're going to get 7 negative 2y Okay. Then we're going to go ahead and we're going to subtract our 7 from both sides. We end up with negative 2y equals negative 10. And we're going to finish off by just dividing both sides by negative 2 to end up with y equals 5, right? Now remember that because we're trying to describe a point on a coordinate grid, right, a place where these two lines cross, that cannot be done solely with a y value. It's good to have that. We're about halfway through the problem, but we're not completely done, right? We have to find a y value. We also have to find an x value. And so what we're going to do is we're going to take that y value and we're going to plug it into either equation, whichever one we feel the most comfortable with. I'm going to pick the top one just because everything's positive. No real negative signs to mess things up for us. And we're going to go ahead and plug that y value in. So it's going to read as follows. Instead of x plus y equals 7, we're going to turn that into x plus 5 equals 7. Remember, that 5 is coming from the y value we found after we performed substitution the first time. Now all we have to do is subtract 5 from both sides because now our focus is on solving for x. And we end up with the statement x equals 2. So solving with substitution helps us get this solution to this linear system. And so we know these two lines cross at the point 2 on the x-axis, 5 on the y-axis. That is our solution. If we plug these x and y values into both of these equations, it's going to make them both say something that is true. Okay? So that's substitution. And what we should understand is substitution is great. It helps us solve situations where we might not be able to graph. But in certain cases, substitution is not the easiest way to solve a system of equations algebraically. If we can't solve with substitution, there's another method we could use called elimination. In a little bit, I'm going to show you exactly how much easier it is to solve this system with elimination than it is with substitution here. But before we get into that, I want to walk you through just kind of the process of solving with elimination. All right? So I'm going to pull out of my screen here. I'm going to scroll out a little bit. We're going to take a look at the worksheet on the left side of my screen here. This matches the worksheet that you have in front of you for those of you that are following along for the stations activity. So if you're doing so, now's a great time to get that out because we're getting into your first task. All right. So we have Tony here who is trying to find the solution to this system. 2x minus 4y equals 12, and 3x plus 4y is equal to 48. All right? I've written it on the side here so we can kind of work it through and then figure out the appropriate responses to each of the steps we'll be performing to solve this system. Okay? So, Tony's trying to find the solution to the system as it reads there using elimination. He wrote these steps to help solve the problem on note cards, but they got mixed up. So we have to reorder these note cards so they're in the correct order. They read the correct steps in which you would take to solve this system. So if I were Tony and I was looking at this system of equations here, I would notice that our two coefficients for y, right? We see negative 4y and positive 4y. And what we notice about each of those coefficients is they're opposites, right? Negative 4 is the opposite of positive 4. So if I'm Tony, I'm looking at this and I'm going, well, I know that I can solve this system with elimination. It's set up pretty nicely to do so because both of my equations are in standard form. And we have coefficients for y that are set up to cancel out if we combine these two equations. Keep in mind, the reason that we're allowed to do that is because, remember, we're looking for a solution, a place where the x's and the y's in these two linear functions are the same. So you can kind of think of this as combining like terms, right? These x's I know are the same exact x, so I can put 2x and 3x together. These y's are exactly the same y, so I can put negative 4y and positive 4y together. I'm going to do the same thing with the resulting constants at the end of these equations, all right? So we're going to go ahead, we're going to combine everything together, all right? you can make this one big addition problem. And we're always going to be referencing that plus sign as we move through this, all right? So if we do 2x plus 3x, these first two x terms here, 2 plus 3 is 5, x plus x as well. That's going to be an x term. So 2x plus 3x is going to give us 5x. Like we said before, if we have negative 4y plus positive 4y, combining opposites here is going to cancel out those terms, right? So we can slash them out, kind of like if we were solving an equation. And over here on the right side, we're just going to go 12 plus 48 is going to get us 60. Okay? So what happened here was we combined these two equations, again, because the x's are like terms and the y's are like terms. And when we combine these two equations, what we notice is we've eliminated one of the variables, y. So step number one here is just that. What we can say Tony does here is he combines these two equations to eliminate one variable. So step number one is that. Okay? You can write that down on your worksheet. All right, now that we're over here with Tony, working through the second part of this, I noticed that I have an equation now that just has an x in it. And that's nice because if my equation has two variables, I can't do much. I can solve it for one variable. I'm going to get an expression for an answer. But now because we have this one variable x, we can go ahead and solve for it. We can solve for it pretty easily. We're just going to go ahead and divide both sides by 5. Dividing the left by 5 gets x by itself. Dividing the right by 5, 60 divided by 5 is 12. All right? So what we end up with is this solution for x. We know that x is equal to 12. And so that second step that Tony would perform here is solve for x. All right, go ahead and make these bigger so that y'all can see at least a little better here. That's good. All right. So now that we have this value for x, right? We know what x equals. We no longer need to use that variable, right? Remember, variables represent unknowns. If we know the value of x, we can go ahead and we can just say that x is 12 now, right? So our next step is going to be finding a y value. Because remember, if we're looking for a point on the graph, we can't just describe that with one value. We need two. How far left or right is it? That's our x value. How far up or low is it? That's a y value. So we still need to find our y value. And the best way to do that is going to be, for step number 3, we're going to substitute the value for x we just found, 12, to solve for the eliminated variable, which was y, right? That's what we eliminated when we combined these two equations. And the beauty of that is that we can plug 12 into whichever equation we find to be the easiest. Let me go ahead and plug it into the first one just because it looks like we're plugging in x. It seems like that'll result in a smaller number. We like working with smaller numbers generally. So I'm going to go up. We're going to write that first equation. Instead of 2x minus 4y equals 12, we can go ahead and say 2 times 12 minus 4y equals 12. All right? All we did was substitute 12 in for x because that was the value for x that we found. And now that we've done that, we're going to go ahead and perform our next step, which is going to be solve for y, right? Once we do that substitution, all we got to do is solve for y. Okay? So let's go ahead and do that. If I want to solve for y here, the first step I should take is simplifying here. That just means multiplying 2 times 12. And rather than rewrite that, we just go ahead and do that multiplication. But I'll draw the little arrow to show that's what we're doing. 2 times 12 we know is 24. So 24 minus 4y equals 12. Now that we've simplified, it's time to start solving. It's time to start getting rid of terms we don't need. Now that we've got that 24, let's go ahead and subtract it from both sides. Okay. 24 taken away from the left side cancels out with that positive 24. We're left with negative 4y. And over here on the right, 12 minus 24 is negative 12. So we're left with negative 4y equals negative 12. And there's just one more thing we need to do to solve here. That is divide by negative 4. That leaves us with our negative 4's cancels out. Y is by itself. And negative 12 over negative 4 is positive 3. So that is our y value for a solution. Okay? And that's it. Once we say we know that x is 12 and we know that y is 3, we have our solution. We have the point where these lines cross. That is going to be at the point 12, 3. And so that is going to be the last line of our process here. Okay? So that's always how elimination works. Your main goal is to be able to combine these two equations to get them so that one of the variables cancels out. Once you do that, you'll be able to solve for the other variable. You get a number value. You can plug that back into the other equation, find the other variable. Okay? So that is where I'm going to leave this video for right now. We're going to come back and we're going to talk about different practice problems where we may have to make changes to each of our equations to solve, but we can still solve with this process of elimination. So I'll see you in that next video.